Jai Hind everyone. My name is Ashish Dixit. So, dear students, today's topic is a master theorem. This topic is also considered under the DA, Design Analysis of Algorithm, and it's also running in a computer science and engineering branch in a AKTU. Okay. So, what is a master theorem? A master theorem is a mathematical tools to use to analyze the time complexity, divide and conquer algorithm. It's provide a quick and straightforward way to determine the time complexity of the algorithm that follow a specific recursive structure. So we can say that master theorem is a mathematical tools where we will find out or analyze the time complexity like a divide and conquer algorithm, like a quick and straightforward way to determine the complexity of the algorithm. This is the also follow or provide a particular structure. By this structure we will get the time complexity. Okay. So here, when the use of the master theorem कब यूज करते हैं? You can use the master theorem when analyzing the algorithm that can be expressed in the form of a recurrence relation. This recurrence relation is also denoted by this form, means Tn is equals to At n by b plus fn. This. Okay. So here Tn represent the time complexity. Tn the time complexity. And what is the A? A is the number of subproblems. Number of subproblems. And B means this one. This one is the represent the size of the subproblems. This represents the size of the subproblems. And Fn represents the time complexity of the function work done. Okay. So again we will define three types of cases in a master theorem. This is the first case. A case first, if Fn is equals to big O n की power log a base b minus epsilon for some constant epsilon is greater than 0, then Tn is equals to big O n log n की power log a base b. And second thing, this is the case 2, if Fn is equals to big O n की power log a base b, then Tn is equals to big O n की power log a base b log n. Okay. And case 3, if Fn is equals to omega n की power log a base b plus epsilon for some constant epsilon is greater than 0, and if a fn by b is less than kfn for some k is less than or equals to 1 sufficiently large, and then Tn is equals to big O Fn. How to apply the master theorem? First, we will identify the value of A, B and Fn. Second thing, determine which case of the master theorem will be based on the relationship between A, B and Fn. Firstly, we will determine which types of case will be applied in our equation. In a third, apply the corresponding formula from the master theorem to find the time complexity is a Tn. Okay. So here we will discuss about the some cases or some numericals. Okay. Question is Tn is equals to 90 n by 3 plus n. This is the question. Okay. So firstly, this is the question, and here we will compare the given recurrence relation to the master theorem. Compare recurrence relation. Tn is equals to At n by b plus Fn. Okay. So here A is equals to 9, B is equals to 3 and Fn equals to n. Here we will compare all things. Okay. So again, we will find out the n की power log A base b. Log A base b. Here A is a 9 and B is a 3. Then n की power log A is a 9, B is a 3. Then n की power log 3 base 3 का square, then n की power 2 log 3 base 3, then n square, and the value of log A base B yani log 3 base 3, if both are same A and B, then its value is equals to 1. Then we will find out the n square. Okay. Then we will find out the n square and get the value is equals to theta n square. Okay. So here Fn is equals to n. Here Fn equals to n, and we will get the value is equals to n square. Means this value and this value have some basic difference that will be used for a master theorem case 1. What is the master theorem case 1? What is the master theorem case 1? This one. Fn equals to big O n की power log a base b minus epsilon. Okay? So here apply master theorem case 1. What is the case 1? Fn equals to big O n की पावर log a base b log b base a minus epsilon. Then we will get the time complexity is equals to Tn equals to big O n log a. We will get log a base b. Okay. So here this is the n square. Then find out the Fn is equals to n is equals to n की power log a base b and 3 9 minus 1 is equals to find the value n square minus 1 is equals to n. Okay, then what is the value? Then this is the case first. Okay, then this is the case first, and we will get the information Tn is equals to big O. Tn is equals to big O. Okay, Tn is equals to go n की power log a base b means big O n square. Okay, big O n square. This is the solution of master theorem. This is the time complexity. Okay. I'm again repeat that this is the recurrence relation Tn equals to 90 n by 3 plus n. So compare the recurrence relation. Tn is equals to at n by b plus fn. A is equals to 9, b is equals to 3, fn equals to n. Then again we will consider n की power log a base b, n की power log a base b, then a is a 9 and b is a 3. Then we will get the value n की power log 3 base 3, n की power log a base b means 3 by 3, and then we will get the n square. Okay. So again we'll compare that here is a n square and here is a n. Means यहाँ पर n स्क्वायर है और यहाँ पे n है, यानी हमें इसके इक्वल करने के लिए क्या करना पड़ेगा? इस 2 में एक -1 करना पड़ेगा. अब जब कभी भी एप्सिलॉन माइनस किया जाता है in a theorem, whenever we will be less by the epsilon, Then we will apply the case first. What is the case first? Big O, Fn equals to big O, n की power log A base B minus epsilon, and we will get the time complexity Tn is equals to big O, n की power log A base B. Okay, so here we will apply the case Tn Fn equals to n, then log A base B means 9, 3, then we will get the n square minus 1, then we will get the n, then here Tn equals to big O n square. This is the time complexity of this recurrence relation. Okay, any confusion? Okay, we will proceed for our next numerical. Means where we will apply the case second. Let's take the examples. Examples is a Tn equals to T 2n by 3 plus 1 by master theorem. Okay, we will proceed compare. A is equals to 1, B is equals to, इसको we can say that we will write down the Tn is equals to Tn by 3 by 2 plus 1. Okay, then what is the B? B is equals to 3 by 2 and Fn is equals to 1 and Fn is equals to 1. Again we will calculate the n की power log A base B, n की power log A is a 1, B 3 by 2. What is the value of log 1 base 3 by 2 is equals to 0, means n की power 0, and n की power 0 means the value is 1. And compare Fn is equals to 1, and here we will get the value n की power log A base B is equals to 1, means no need that we will use a minus epsilon or a plus epsilon. So here it's a neutral. As it is केस है जो हमने सॉल्व किया है उसमें भी 1 आ रहा है, Fn में भी 1 आ रहा है, यानी हमें ना तो एप्सिलॉन प्लस करना है ना ही एप्सिलॉन माइनस करना है, यानी यहां पर केस क्या लग रहा है? केस 2. Apply case 2. Okay. Fn equals to n की power log A base B. Then time complexity is Tn is equals to big O. Tn is equals to n की power log A base B LGN. Okay, so here the value is, find out the value is 1. Then Tn is equals to theta LGN. this is the resultant, this is the time complexity. This is the resultant and this is the time complexity. Okay, this is the case. This is the case 2. Okay, again we will take the next examples that will be depend on the case 3. It's a very important case. Okay, here we will find out the regularity condition. We will check the regularity condition. Again we will take the next examples. Tn equals to 16 T n by 4 plus n cube. Here A is equals to 4, A is equals to 16, B is equals to 4 and Fn equals to n cube. Okay, and we'll find out the n की power log a base b. What is the log a base b? N की power log a and base b is equals to 4, log a यानी 16. Okay, so n की power log 4 base 4 square, then value is n square, and log 4 base 4, this is the value is equals to 1. So we will get the n square. Got it? So here we will check the condition. This is the n square and this is the n cube. Means यहाँ पर हमें अगर हम प्लस 1 ऐड कर दे मीन्स एप्सिलॉन क्या हो गया हमारा 1. और हमेशा याद रखिए कि जो एप्सिलॉन की वैल्यू है वो क्या है यहाँ पर 1 है. ठीक, तो हम क्या कर सकते हैं, we will apply the case 3rd. लेकिन before the apply the case 3rd, we will check the now the regularity condition. Now we will check the regularity condition. Now check the regularity condition. What is the regularity condition? 16f n की पावर 4 का क्यूब n का क्यूब is less than or equals to c f n cube. Then 16 n cube 64 is less than equals to c f n cube. Okay, so here again 16 n cube 64 is less than or equals to c n cube. N cube is a disconnected, cancel, then 1 by 4. Then what is the c? The value of c is equals to 1 by 4. Or always check condition. So regularity condition is the value of the c is less than 1. Then this is the regularity condition. Then the value of the c is less than 1 means c equals to 1 by 4. So here we will apply the case 3. And what is the case 3? Then Tn is equals to theta Fn. Tn equals to theta Fn. Then Tn is equals to theta Fn means n cube. This is the resultant of the case 3. in a case 3, we will check the regularity condition. After the regularity condition, we will get the time complexity Tn equals to theta n cube. Okay. So I'm again repeat that. In a master theorem, we will study three cases, case 1, case 2, case 3. And always kept in mind, the constant k is less than or equals to 1, means we can say that C, here we will use the C, okay, for a regularity condition. Then case 1, case 2 and case 3. Case 3 is a very important. Then we will find out the k value in our last examples. K is 1/4 and 1/4 is less than 1. Then this is got the regularity condition. Okay. And case 1, case 2 and case 3. So if you face any problems, then comments in a comments box. Thank you very much.